Hey everyone, so today I'm going to be telling you about electromagnetic radiation, which is the same as saying electromagnetic waves, and obviously I need to tell you as well electromagnetic spectrum, so any of these could relate to the same, okay? So EM radiation, so electromagnetic radiation, actually I believe that the first way or the best way for you to start is actually clicking on this link, which I'll put on the description, because it's a really nice video from BBC Bite Size where they explain all the uses and all the properties of each part of the electromagnetic radiation. If you remember some videos ago, I was telling you that the waves could be mechanical or electromagnetic. So these are those electromagnetic waves, the ones that move always at the same speed, which is the speed of light. And the formula that relates to that is this one. So speed equals the frequency, which is this mu, or you can see as f, times the wavelength, okay? The velocity of the electromagnetic waves is in meters per second, and is always the same number. So 3 and then 8 zeros meters per second. So that's 3 times 10 to the power of 8 meters per second. The frequency comes in hertz or 1 over second, and the wavelength comes in meters. This is why the velocity is in meters per second, okay? So check the video on the properties of the electromagnetic radiation. It's a short video and it does have some activities at the end, so I really recommend. Otherwise, this is what we have. So we have the electromagnetic radiation. The waves are all transverse, so they look like this, okay? However, they have different wavelengths. So the length of a complete wave is different, okay? And depending on the wavelength and therefore the frequency, we put them into separate parts, so we group them. So starting from the shorter wavelengths, which means a higher frequency and a higher energy, we have gamma rays, X-rays, ultraviolets, and all of these are known as ionizing radiation. And then if I carry on increasing my wavelength and therefore decreasing my frequency, I get the visible light, which is the only part of the electromagnetic radiation that I can actually see. Then I have the infrared, the microwaves, and the radio waves. And here you kind of have an approximate scale of the size of their wavelength, okay? So atomic nuclei for gamma rays, atoms for X-rays, molecules for ultraviolet, visible light, you have like small organisms, bacteria, for example, infrared, the needle point, microwave, butterflies, and then microwaves, infrared, then microwave goes from butterflies, and then radio you can get from the microwave and radio the size of humans or buildings, okay? And as you can see here, this is the frequency, because, let me show you the formula again, frequency times wavelength equals the speed of the waves, and the speed of the wave is the same. If frequency is high, wavelength is low. If wavelength is high, frequency is low. So that's why as I increase my wavelengths, I decrease my frequency, 10 to the power of 20 to 10 to the power of 4. So I am decreasing my frequency and my energy as I increase my wavelength. So as I go from gamma to radio waves. You need to know them in order, okay? There's also here a scale about the temperature and if they penetrate the atmosphere or not. And as you can see, visible light does, ultraviolet does a little bit as well, and radio waves as well, okay? So more about electromagnetic radiation. So as you could see from the video, the electromagnetic radiation has, depending on the wavelength, different uses. So what I did was I put all the electromagnetic radiation here in order from the shortest wavelength to the longest wavelength, meaning from the highest energy and frequency to the lowest energy and frequency. And I put here some uses which are all jumbled up. Pause the video for you to try the exercise, otherwise the answers are coming up now, okay? So gamma rays, they have a lot of energy, they can kill cells, so they are used for cancer treatment and sterilization, so kill bacteria and medical equipment, okay? X-rays, they are quite energetic as well, not so much as gamma rays, so they will penetrate through your skin, but they do get absorbed by your bones, so they are used for medical images of bones, okay? Ultraviolet is what you see in sunbeds, fluorescent lights, invisible ink. So again, I'm going down in energy and increasing my wavelength. Then we get to visible light, which is the type of wavelengths we can see. So it's about 700 to 300 and something nanometers, so 10 to the power of minus 9 meters. So these are the wavelengths we can see. Visible light is then used for seeing. Infrared radiation, so now is non-ionizing radiation. The most thing that they do is heating up. So infrared radiation is going to be used in optical fiber communication, remote controls. You can also use it in optical fibers along with visible light. And when you're heating up something, you are providing that something with infrared radiation, okay? Microwaves are used for cooking and mobile phone signals, sometimes some TV signals as well. So the microwaves, they heat up the molecules of water in your food, and this heats your food. And finally, we have the radio waves, which are used for TV and radio signals, okay? So these are the radiation types and their uses within the electromagnetic radiation. Remember, they are all electromagnetic, they are all transverse, they all travel at the same speeds. Now, there are risks and benefits of using electromagnetic radiation. So what are these? So the risks: any radiation above the visible light, so gamma, X-rays and ultraviolet, is very energetic and can cause mutation in our cells, developing into a cancer. More detail on this in other videos, okay? There is one actually that you already had this much detail. And benefits: radiation is widely used in communication, cleaning, medical purposes, including killing cancer cells and sterilizing equipment. So obviously is very necessary as well. So you kind of need to balance the pros and the against, or the benefits with the risks, okay? So you need to use it in the right way, basically, okay? Now, I have here, this is from Footprint, so all the other stuff was mine apart from that picture that I got from the internet. I have here an exercise with microwaves and one about radio waves. And I also have here these videos that I can put in the description. They are from NASA, I suppose, or Discovery Education, something alike, and they are so interesting. So feel free to go to them and get to know a little bit about this, and then you can actually see the whole electromagnetic spectrum. So we have here a sentence and some words are missing, and I want you to decide, before I carry on, decide which are the right answers for these words, okay? So which are the right words that I should have in each cloud. So pause the video if you don't want to try, otherwise I'll just show the answer straight away. Radio waves are used in radio and television communications. Longer wavelength radio waves are reflected from the ionosphere in the Earth's upper atmosphere, and this allows them to be sent further. Remember when I told you about diffraction? This happens with very long wavelengths because, you know, they see the Earth's atmosphere, so they see this as a gap. And because they are reflected, they can be sent further from this distance to this distance because they are not passing through the atmosphere and they are sent back down, okay? So that's for radio waves. I have here one for microwaves, if my computer, yeah. So again, the same. Try the sentences, or try to fill in the gaps without my help. Also, there is this amazing video about from the same NASA or Discovery School about microwaves. Again, using those videos, you can go to the other videos about the other parts of the electromagnetic spectrum and try this. Otherwise, I'm going to show you the answers now. So freeze either freeze or then just listen now. So microwaves, they pass easily through the atmosphere, and therefore they are going to be used to send information to and from satellites. They are used in mobile phone networks, and microwaves of a certain frequency cause water molecules to vibrate, and therefore they are used in cooking. Alright, so we know about the electromagnetic spectrum in order. We know about the uses, we know about risks, we know about benefits, and I gave you enough links and exercises really for you to get more information about all the other parts of the electromagnetic spectrum. So I'm just going to give you here, again, if my computer cooperates, a quick quiz, which is also not mine, is from Footprints, okay? I don't know how to do these animations. So which of the following has the shortest wavelength? That's going to be gamma. Next one, which of the following, so always pause, try to think before I give the answer. Which of the following is used to look at bones? So that's going to be X-rays. So then you go, you have the option of X-rays. Radio, microwaves, infrared, light, ultraviolet, X-rays and gamma waves are all, so I have here all the parts of the electromagnetic waves. Alright. Next one. Is the following statement true or false? All electromagnetic waves travel at the same speed, which is the same as the same speed of light. That is true. Next exercise. Which of the following causes your skin to produce melanin? So melanin is when we get a tan. And if you look at these sunscreens, they say they have these sun protection factor, so SPF, and the sunscreen as well. They say if what they block you against. So they always say UVA and UVB. Sorry. Which are the most dangerous of all the UV radiation. So that's going to be ultraviolet. So the melanin is your natural response to protect you from the sun. It makes your skin darker, but of course it's not enough, okay? A darker skin color person has more melanin than a lighter skin person. More stuff, more exercises. Which of the following is used in cooking and mobile phone networks? So that's going to be the microwaves. Something rays can cause cancer, but also can be used to treat cancer. So that's the gamma rays. Whenever you have these exercises, always look at don't look at the options straight away. See if you know the answer in order not to get influenced by the options. Is the following statement true or false? Radio waves have the highest frequency of all electromagnetic waves. That is false. They have the highest wavelength, the longest wavelength, the lower frequency. So that is false. Okay, so that is it about introducing you to the electromagnetic spectrum. I hope it made sense. Up to my next video. Be happy and healthy. Bye.